Good day everyone. We are here again with another model, now for another impossible construction, popularly known as doubling a cube. First of all, what is impossible construction? Well, in mathematics, a construction is something that you can do. You can construct something with the help of only two things: a compass and an unmarked ruler. So this ruler won't do because it has marks on it, but an unmarked ruler. So you can simply draw a straight line with it, that's all. Now it has been proved mathematically that this particular construction, doubling a cube, is impossible with the help of only these two tools. And so we are now going to construct it with the help of a model. Coming to the meaning of doubling a cube, what exactly does it mean? It means that given a cube, you are given a cube, you have to construct another cube which is double of this. Double means this is a 3D thing and it has a volume. Like if I want the double of a line segment, I would take double the length. Here I will take double the volume. So if the volume of this is known to me, I have to take the double of that volume and construct a cube whose volume is that, double of this. Now, we are not actually going to construct cubes. We are going to reduce it to a very simple problem, and that is that if I have a cube, suppose this is my cube, I call this side 1 unit because I am not given any length. So whatever the side of this given cube, I will call 1 unit. Then what is the volume of this cube? Well, the volume of this cube is 1 cubic unit. Okay, I want a cube which is double the size, which means 2 cubic units. What should be the size? Suppose I want a cube and the side is going to be, the volume is going to be 2 cubic units, or 2 in short. What should be the side of this cube? It should be cube root of 2. So that cube root of 2 into cube root of 2 into cube root of 2 will make the volume 2. So basically what it comes to is finding the cube root of 2 or constructing the cube root of 2. Now you know, constructing square root 2 is not difficult. Take 1 unit, take another unit, and then this will be square root of 2. But no such construction is possible for cube root of 2. Otherwise, if it were possible, we will take that much length and construct a cube. Then it's not difficult. Okay, so now what do we want? We want to construct cube root of 2, and we have a model for this, and the model is this. We have a square tray with border all along so that we can have the support of it. We have two such rectangular strips. One goes inside and one goes on it. On it means on the border, on this green and on this. So it will go like this. We should be able to move this like this, and this one over here. Now we have another, and that is the most important thing. Two straight lines, actually supposed to be straight lines, but we have taken two sticks, join at right angles, so they are perpendicular to each other. On one of them, the horizontal one, we have marked 1 unit. What is 1 unit? We don't know. Suppose this is the given cube and we want that 1 unit, then we shall take this much. If this is your 1 unit, we shall take this much. So this is our unit, whatever it is. Once we take this unit, now we are fixed. We have to take 2 units along the vertical one. So 1 unit here, 2 units here. Suppose you want 1 unit to be this much, okay, this will be your 2 units. So that is how we have marked 1 unit here and 2 units here. And now these are the 3 pieces of the model. what we have to do is, we have to place this on the tray, the cross made of sticks, in such a way that the mark for 1 unit lies on this horizontal base. It does not just now. It should like this. Okay? And the mark for 2 units corresponding to this one, this is 2, it should lie on the vertical, like this. Okay, one part is done. That's not all. Now it should be such that if you place this over here, what have I done? At this point, I have placed this horizontal strip. Now I am going to place a vertical strip, and if I put it here, you can see, what do I mean by here? Where this strip crosses the stick. Now then, you can see that this point is far away. I want these 2 points to be vertically aligned. And for that reason, we will have to move this. And how shall we move? Well, we keep moving this. We are moving this. Now, you cannot see my upper point because my thumb is there, but I have to hold it here. And we are taking this, moving it like this so that this will lie here. And this should come vertically below the top crossing. This crossing and this crossing should come below each other. And now you can see that these 2 will come below each other. So now that is the point. Now this was what, once you take this, you can see that the green strips form 2, they are at right angles, these 2 are at right angles, and the whole becomes a rectangle. And this is 1 unit, this is 2 units, and we say that the length on this rod here, on this stick here, it has moved, but I guess you know what it is now. This, and this length here, with the green vertical one and this orange cut on this stick, all 3 meet here. This length we say will be our cube root of 2. Now the construction is over. Once we get this length, we take this much length and construct a cube. That's all. This is the length of the side of the cube. But that's not all. In a construction, we cannot say that here is this length and that is cube root of 2. We have to prove that it is actually cube root of 2. And for that purpose, what we do is, I will draw here so that we can check the whole thing. Our model was something like this. This was 1, this was 2. And this was the green strip here, and this was the green strip here. Now what we are going to say is that this length, if we call x, then x is equal to cube root of 2. And now we want to prove it. Now in order to prove that, I will erase the extra part so we see only the relevant portion. You can see that these 2 are parallel, opposite sides of a rectangle. These 2 are opposite sides of a rectangle, and therefore these 2 triangles, one at the top and one at the bottom, will be similar. These 2 angles are equal. These 2 angles are equal. And naturally vertically opposite angles, or the third angle has to be equal. Now we have 2 similar triangles. Suppose we call this y. What shall we have? 2 is opposite this angle this angle and opposite to that is x. So 2 upon x. Now 2 was opposite to this is y. Opposite to the circle here is 1. So this is one relation we get out of two similar triangles. The other thing is that as we notice this was a right angle and therefore, rectangle, and therefore this is a right angle. Also our sticks we constructed mutually perpendicular, so this is also a right angle, and therefore what we have now is in the right triangle A, B, C, if we call this P, in the right triangle ABC, AP is perpendicular to the hypotenuse, and so AP square is equal to BP into PC. Or in other words, y square, AP square is 2 into x. So we have these two relations. We are not interested in y, we want to know something about x. So we try to eliminate y. Y from here, as you can see, is 2 upon x. So we put here both these two together. So y is 2 upon x, so this will be 4 upon x square, and this is 2x. Now 2 will cancel out and we shall be left with only 2 here. X square on the other side will give us x cube, and you can see now that x is such that its cube is equal to 2, or the cube root of x, cube root of 2 is x. Also, when we constructed this, if you recall, we had something like this, and there was a strip like that, and this much was our x. Now it so happens that you can see here that this is your 1 unit, and your x is supposed to be cube root of 2, and this is your cube root of 2. So it's a matter of chance that the cubes that I have are such that if this length is 1, this length is cube root of 2, or in other words, here is a cube which is double this cube. And how did we get it? By this model. Okay, thank you.